Hey everybody, today we are looking at section 6.5, which is conditions for special parallelograms. In the last section 6.4, we talked about rhombuses, rectangles, and squares, and what all specific properties that they had just for those figures. In this lesson, we're going to do similar to what we did with 6.3, where we're going to say, okay, I have these properties. Do I have enough to know that I have a rectangle, a rhombus, or a square? All right. So the first things that we're looking at is if we have a parallelogram with one right angle. So I've got a parallelogram because opposite sides are opposite sides are parallel. And I have one right angle here. I know that I have a rectangle. That's enough information to know because I know opposite angles are congruent. And consecutives have to be supplementary. So that gives me 4 right angles, which gives me a rectangle. Okay, if I have a parallelogram with congruent diagonals, then that is also enough information to know that I have a rectangle. So again, a couple of key things that we are going to need to know first with a lot of these is that we're going to have to know that we actually have a parallelogram. All right, that's going to be an important piece of information, is that we have to be able to show that I have a parallelogram and then show a rectangle property or a rhombus property. But again, knowing that parallelogram is going to come first. Okay, if I look at rhombus, it's going to be the same thing. I need to know first off that I have a parallelogram, and then if I have consecutive sides congruent, that's enough to know that I have a rhombus. Because remember, opposite sides are congruent. So if this gets 1 slash, this would get 1. If this gets 1, this would get 1. So then they're all 4 congruent. All right, so that's how we would get our definition of a rhombus. All right, parallelogram with one pair of consecutive sides congruent. Next, again, I'm told first that I have a parallelogram with perpendicular diagonals. That's a rhombus. And a parallelogram with one diagonal bisecting opposite angles. So these 2 angles are congruent and these 2 angles are congruent. In order to show something is a square, you need to know parallelogram. You need to have a rectangle property and a rhombus property. You have to show something for all 3 to show that you have a square. Because if you just have a parallelogram with a rhombus property, then all you know is that you have a rhombus. You don't have enough information to know that it is a square. So that's going to be kind of important, is that we are proving all 3 pieces when we're trying to show that we have a square. So let's take a look at what this does. All right, we have a contractor built a wood frame for the side of a house so that XY, so we're going to make this a little bigger so it's easier to see. This side here is congruent to WZ, and XW is congruent to YZ. All right, so right there with just that first sentence, I know that I have a parallelogram, all right, because my opposite sides are congruent. All right, using a tape measure, the contractor found that XZ, which is this diagonal, the length was equal to WY, all right, which is our other diagonal. So we have a parallelogram with congruent diagonals. That is a rectangle. Okay, so we need to show first, we need to talk about, because it's a parallelogram, so we know that since both pairs of opposite sides are congruent, then XY, or we'll do WXYZ, is a parallelogram. Okay, so that's step 1. We have to show parallelogram first. Then we can say that since XZ is equal to WY, the diagonals of WXYZ are congruent, which is a property of a rectangle. Okay, so again, we need to show first we have a parallelogram property. So our opposite sides are congruent. So I know I've got a parallelogram. And then my diagonals are congruent, so that gives me the rectangle. All right. Let's take a look at the next one. We want to know whether or not the conclusion is valid. All right. So when we're looking at determining whether or not a conclusion is valid, we've got to see, okay, do I have enough information? So like if I'm trying to show a rectangle or a rhombus, I need to have a parallelogram property, and then I need to have the property of a rectangle or a rhombus. Again, if I want to show that I have a square, I have to have a property of all three figures. So when I look here, all right, I'm given that AB is congruent to AB is congruent to CD, BC is congruent to AD, these sides are perpendicular and these are perpendicular. I want to show that ABCD is a square. So if you look at your notes, the first thing is broken down into 4 steps. So step 1 is ABCD a parallelogram? Okay, so step 1, we're trying to conclude whether or not we have a parallelogram. All right. So if we mark the information that we're given, I'm given AB is congruent to CD, BC is congruent to AD, AD is perpendicular to DC, and AC is perpendicular to BD. Okay, so that's all the information that we were given. So if we look to determine whether or not we have a parallelogram, okay, I have here opposite sides are congruent. So that's that AB is congruent to CD and BC is congruent to AD. So ABCD is a parallelogram because opposite sides are congruent. Okay, so that's our parallelogram property first, is that we have opposite sides are congruent. All right, then we're going to switch to step 2 here. Now, if you look at step 2 in your notes, the question that we are asking is ABCD a rectangle? Okay, so that's the next piece. So let's look at what else we have in our picture. Okay, we've already used the fact that my opposite sides are congruent. Okay, look right here. I have a parallelogram with one right angle. That is going to make my rectangle property. So that means all 4 angles are right angles. Okay, so I can say AD is perpendicular to DC. So angle ADC is a right angle. Therefore, ABCD is a rectangle. Okay, that was one of our theorems right at the beginning, is that if we have a parallelogram with one right angle, that's enough to know we have a rectangle. All right, next, if we look at step 3, okay, the question says, is ABCD a rhombus? Okay, so that's the next property we want to look at. All right, we've used the fact that our opposite sides are congruent. We've used the fact that we've got one right angle. Look what's here. We have that the diagonals are perpendicular. Okay, so we have that AC is perpendicular to BD. So my diagonals are perpendicular. Because my diagonals are perpendicular, we have a rhombus. All right. And then the last thing on your notes is step 4. Okay. It says, is ABCD a square? So ABCD is a parallelogram, a rectangle, and a rhombus. so it is a square. Again, I can't stress enough, guys, to show that you have a square, you have to have all these properties of a parallelogram, a rectangle, and a rhombus. You have to have one that is specific to each of those properties. All right? So rectangle, you've got two choices. All right? You've got your sides are perpendicular, so you've got 4 right angles, or your diagonals are congruent. Okay? For your rhombus, you've got that your diagonals are perpendicular, that they bisect opposite angles, or that all 4 sides are congruent. Okay, and then our parallelogram properties, opposite sides congruent, opposite angles congruent, opposite or consecutive angles are supplementary, opposite sides are parallel, or diagonals bisect each other. So each set of those is going to describe a certain polygon. All right, you have to have all 3 of these to be able to conclude that we have a square. Okay, let's look at part B. Part B is going to use this same picture. All right, and all it tells me is that AB is congruent to BC. And I want to show that it's a rhombus. Okay, so the first thing that I need to show for a rhombus is that it is a parallelogram. We do not have that information here, okay? I only have a rhombus property. I have a shape that we're going to talk about in the next video in 6.5 that is called a kite, which has 2 pairs of consecutive sides congruent. This could be a kite. We don't have anything that says that it's not, okay? So this is not a valid conclusion. Okay, we need to know a parallelogram property. Okay, so again, for a rhombus, you've got to know a parallelogram property and a rhombus property. You've got to know both pieces. Okay? All right, let's take a look at our next example. Okay, I am going to be given coordinates, and I wanted to be able to determine whether the parallelogram is a rectangle, a rhombus, or a square. So the key thing here is that we are told it is a parallelogram. All right, I do not have to prove that it's a parallelogram. It is already given to me. All right, so let's take a look here. I'm going to start at 0, 2 for point A. Actually, I'm going to up the size of my line here a little bit. Hold on. Okay, so A is at 0, 2. B is at 3, 6. C is at 8, 6. D is at 5, 2, and then we finish our figure here. Okay, so this is A, B, C, and D. Okay, so I want to know, first things first, I'm told parallelogram, okay, and then I want to know whether or not I've got a rhombus or a rectangle, or neither, just a general parallelogram. So again, one of the things that I want to go through here is I want to show for rhombus, I'm just going to use my diagonals, all right? Because honestly, I think using your diagonals is probably one of the easiest ways to do this. All right, so in order to look at, is it a rhombus? Okay, my rhombus property is that my diagonals should be perpendicular. So I'm going to use slope. All right, so I'm going to find the slope of AC, which, remember, slope is y2 over y, or minus y1. So slope is y2 minus y1 over x2 minus x1. And we're going to use distance 2, which is the square root of x2 minus x1, quantity squared, plus y2 minus y1. That's not a y. Pardon me. y2 minus y1, quantity squared. Okay? So I'm going to start by determining, is it a rhombus? So I'm going to look at the slope of AC, and y2, let's just say that this is going to be x1, y1, and then AC, so x2, y2. All right, so I'm going to do y2, which is 6, minus y1, which is 2, over x2, which is 8, minus x1, which is 0. So 6 minus 2 is 4. 8 minus 0 is 8. I have a slope of 1/2. Okay, then I'm going to do the slope of BD. And I'm going to go ahead and just write this in green. I'm going to do x1, y1, and x2, y2. All right, so this is going to be my y2, which is 2, minus my y1, which is 6, over x2, which is 5, minus my x1, which is 3. So 2 minus 6 is negative 4. 5 minus 3 is 2. So I have a slope of negative 2. Okay, if I look at these two slopes, they are opposite reciprocals of each other. So they are perpendicular. So I do have enough information to know that this is a rhombus. Okay, now, I fully understand that we can look at this picture and this graph and know pretty instantaneously that it is not a rectangle. Okay, I get that. I understand that. I am with you. However, we are going to go ahead and show that it is not a rectangle, because you might get one that is. So our rectangle property with diagonals is that our diagonals are congruent. So we're going to use distance. All right, so I'm going to find the length of AC, which is the square root of x2, which we're using the red numbers here. So it's going to be 8 minus 0, quantity squared, plus y2 minus y1. So 6 minus 2, quantity squared. All right, this is going to simplify to 8 minus 0 is 8. 8 squared is 64. 6 minus 2 is 4. Squared is 16. This is going to give me the square root of 80. All right, then we're going to do the length of segment BD. All right, so now we're looking at our green numbers up here. So x2 minus x1, we're doing 5 minus 3, quantity squared, plus y2 minus y1, so 2 minus 6, quantity squared. All right, 5 minus 3 is 2. 2 squared is 4. 2 minus 6 is negative 4, and negative 4 squared is 16. So this is going to give me the square root of 20. All right, if I look at these two, they are not equal. So we do not have a rectangle. So we know that ABCD is a parallelogram and a rhombus. Okay, it is not a rectangle. Okay, and since it is not a rectangle, it cannot be a square. All right, so that is part A. And we're going to go ahead and look at part B. We're kind of going to do the same thing. And what I'm actually going to go ahead and have you guys do is go ahead and try this one on your own. Go ahead and graph it and go through the properties of a rhombus and go through the properties of a rectangle, just like we did on the last one, and determine whether or not you've got a rectangle, rhombus, or square. give any of the names that apply. So go ahead and pause the video and give this one a shot on your own. And then we'll go through the answers real quick. All right, so go ahead and check your answers. All right, notice that our slopes are not opposite reciprocals of the diagonals. So if we draw on our diagonals, they're going to go here and here. I did not put that in. Okay. Our diagonals are not opposite reciprocal slopes. So we do not have perpendicular diagonals, and we do not have a rhombus. Since we do not have a rhombus, we do not have a square. All right. If we look at the rectangle, I'm looking at the lengths of the diagonals. Okay, they are congruent. They are the same length. So we know that EFGH is a rectangle and a parallelogram. Okay, but it is not a rhombus, so it cannot be a square. All right. So now what I want you to do is in that left-hand column of that example we were just kind of working on, underneath it says, in the directions where it says give all the other names that apply, I want you to write this information in there. Okay. So if I want to use sides, because what we did with the rhombus and the rectangle in the example was we used the diagonals, because in the directions, it actually says use the diagonals. Okay. But I want you to have information written down of how we can do this using sides. Okay. So, for your rhombus, you're going to show two consecutive sides are congruent by using the distance formula. All right. Because again, we were given parallelogram. And for the rectangle, we can use our slope to show that my consecutive sides are perpendicular. So if I like distance, I can do two sides are congruent for distance, and then the diagonals are congruent for a rectangle. If I like slope, I can show for a rectangle that consecutive sides are perpendicular and the diagonals are perpendicular using slope. Okay, so there's a couple of different ways that I can show this. Again, we use the diagonals because in the last example, it actually said use the diagonals. Okay, but please make sure that you do have this written down in that last column of your notes. All right. And then that'll do it for us for today. So I hope you have a fabulous day, and I will see you guys later. Bye.